Hello all, welcome to your instructional piece on Unit 7.4, solving quadratic equations. This is identical or very similar to the last section, except instead of just factoring and stopping, you're actually going to solve each problem and get a final answer. I'll give you an example. Here's example number 1. If I have an equation 2x squared equals 32, and I need to find x, this problem is one of the easier ones because it doesn't have an x squared and an x. So in this problem here, you're just going to do what you normally do, and that is get the x alone. So you divide by 2, you divide by 2. You get x squared equals 32 divided by 2, which is 16. And to get rid of a square, you take the square root of both sides. Square root of 16 is 4, so x equals 4 is my answer. Now, with quadratics, you should usually have two answers, and that's why the only answer isn't just 4, it's also negative 4. The reason why is if you take this negative 4 and substitute it back into the original problem, let's take a look. 2 times negative 4 squared. Negative 4 times negative 4, when you square that, you still get 16, whether it's a 4 or a negative 4, and that results in 32, which is the answer that you wanted. So for these problems, once you take the square root of a square, that's when you need to put like a plus and minus in front of your answer. You can certainly write your answer as both the positive and the negative 4 instead of writing it out separately at two different times. That's example 1. Now for example 2, example number 2, this is going to be a little bit more difficult when you have an x squared and an x. So 2x squared plus x equals 15. For a problem like this, you should not solve any quadratics unless they equal 0 first. So I'm going to swing this 15 over from the right side to the left side. And that'll then give you 0. 0 equals 2x squared plus x minus 15. Now we've done the quadratic formula and we've done completing the square, but this is factoring. So factoring would be problems you can do without a calculator. For this problem here, I'm going to solve this by factoring. Now I could use completing the square, I could use quadratic formula, but factoring goes easier in this case. Once again, I like the guess and check method. What times what is 2x squared? 2x and x. What times what is 15? That would be 5 and a 3. Now it could be a 3 and a 5, it could be 15 and 1. So I like to mess with my outers and inners to see if I can get that middle answer of positive 1x. My outers, 6x. My inners, 5x. Ooh, this is going to work out lovely. So then if I check this, I want a positive 1 from the middle there, so I need to get a positive 1, so the 6 has to be positive, the 5 has to be negative. So the negative 5 here, positive 3 here. So this is how you get this problem. Let's just double check. 2x squared, 6x minus 5x is 1x, and then negative 15, negative 15. It all works out good. To finish this problem, once again, you're going to have two answers. You take the first part, set it equal to 0 and solve. Add the 5 to both sides. Divide by 2. 5 halves, or 2.5. And then you take the second part and set it equal to 0. X plus 3 equals 0. Minus 3 to both sides, you get x equals negative 3. If I take either of these solutions and plug it back in for x, I would end up to get 15. And if I did it with the other one, I'd also end up to get 15. So that's how you solve quadratics. That can be done by factoring. Next. That would be example number 3. Now, sometimes I'm going to ask you to work backwards. I'm going to tell you what the solutions are. So the directions on your worksheet say something like this. 2 and negative 3 are solutions. I might call them solutions, S-O-L, solution. I might call them roots. I think I call them roots on the paper. And I might call them zeros. All of these things are interchangeable. Solutions, zeros, and roots. If these are the roots of the function, or the solutions, you need to come up with the original quadratic function. So now you need to work yourself backwards. So working backwards means you write this the same way we did in the last step on the last problem as that FOILed part. If these are the solutions, my answer is going to be x minus 2. Well, why? Because if my solution is 2, and I took this x minus 2 part, set it equal to 0 like I did in the last problem, when I add 2 to both sides, I get that number 2. So I'm going backwards. So to go backwards, I need to swing this 2 back over to the other side, and that's why it becomes a minus 2. In other words, if it's a plus like it is here, you just make it a minus. This one's a minus, so you make it a plus. Why is that? Because if I bring the 3 over to this side, it would become negative 3, which is what I got for an answer. So it's kind of working backwards. Now, this is not quite a quadratic equation because I don't have x squared, so I have to FOIL it out. X times x is x squared. X times 3x is 3x. Negative 2 times x is negative 2x. And negative 2 times 3 is negative 6. Combine your middles. You get x squared plus x minus 6 equals 0. That is the quadratic equation I solved to get my original problem of those zeros or roots. Last problem. Now I'm going to do the same thing, but I'm going to add one trickier extra aspect to it. Life doesn't always end up to be nice, perfect numbers. So this is example 4. Let's pretend my solutions are something weird like 2/3 and 3/5. I'm going to do this the exact same way as the last one. I'm going to go x minus 2/3 and x minus 3/5. Now remember, if one of these was negative, I would change this to a plus, and then equals 0, and then I FOIL it again. X squared, x times negative 3/5, negative 3/5 x. Negative 2/3 times x, negative 2/3 x. And then 2/3 times 3/5, that would be 6/15. Yes, negative times negative is a positive. Okay, now this is my quadratic equation, but like I did on the last one, I'm going to have to simplify it. So I take these two middle terms and add them, get common denominators. Hopefully you know how to add fractions. Use a calculator if you don't really like to. It ends up to be 9/15 negative. And then you still have the 6/15 out back here. Almost all the time with these problems, you're not going to see fractions. So what I'm going to do is I'm going to get rid of my denominators here. To get rid of my denominators, I have to multiply everything through by 15. Even the 0, although it doesn't make any difference because it cancels out. 0 times 15 is 0. 15 times x squared is 15x squared. Here's the key part. Why I'm doing this is I'm doing this to get rid of those denominators. I get negative 9x. And I get rid of these denominators and I get positive 6. If I factored this and set it equal to 0 and solved, I would end up to get these original solutions. That's a quick shortcut version of explaining all this. Hope it works out for you. There are some story problems, but I will cover those individually in class. Thanks for listening.